Hello everyone, my name is Nataliia Romanyshyn and I am excited to share my research topic with you, automated extraction of hypo-Hypernym relation for the Ukrainian WordNet. I am fortunate to be guided by my supervisors Dmytro Chaplynskyi and Mariana Romanyshyn. So to begin with, WordNet is a comprehensive lexical database that illustrates the semantic relations between words in a language. It plays a crucial role in various natural language processing and understanding tasks, including word sense disambiguation, machine translation, and text summarization. The journey of WordNet began in 1994 with the publication of the Princeton WordNet. Researchers working with languages other than English quickly became interested in this field and proposed numerous automatic methods for constructing and expanding WordNets due to the high cost of manual taxonomy creation. As a result, there are now WordNets available in over 200 languages. However, Ukrainian still lacks a publicly available WordNet. The main built-in block of WordNet is the synonym set or thin set. A thin set represents words with similar meanings that can be interchangeably used in a given context. Each thin set also includes a clause and a part of speech and is connected to other thin sets through lexico-semantic relations. In this work, we focused on nouns and hypo-Hypernym relations. This relation reflects the hierarchical structure of WordNet by linking general terms to more specific ones. For example, rose is a hyponym of flower, which is a hypernym of rose. Words that are hyponyms of the same hypernym are called co-hyponyms. The main objective of our project is to propose a new methods for building the foundation of the Ukrainian WordNet using available multilingual resources. To develop an algorithm that links articles from the Ukrainian Wikipedia to the census of Princeton WordNet. Create an algorithm for prioritizing the gaps in the obtained resource and develop strategies for the automated generation of candidate words to fill the gaps. Preliminary work on the creation of the Ukrainian WordNet dates back to 2008. However, previous efforts were generally limited in scope, primarily focused on manual creation or were not publicly available. The solution we propose involves several main steps. First, we construct a base using the Princeton WordNet as a root structure and link it to the Wikidata and the Ukrainian Wikipedia. The resulting tree contains nodes that could not be linked to the Ukrainian Wikipedia, thus lacking a Ukrainian equivalent. We call this gap nodes and propose the simple gap ranking algorithm to identify the best gap nodes fulfilling. The next step involved generating candidates terms using machine translation, Hypernym Discovery model, and generative AI. In the final stage, professional linguists will manually annotate the automatically generated candidates using the developed application. The linking procedure is as follows. We start by looking for a Princeton WordNet synset that is linked to Wikidata using the synset ID. Next, we find the Ukrainian Wikipedia article in Wikidata. Then two options are possible. If the search in the previous step is successful, we have a word to fill the node of our tree. If not, we temporarily store the English lemma from PVN at this node to fill the gap later. Finally, we find the hyponyms of this inset and continue the process until the end of the tree. This slide demonstrates the construction of a subtree for the windstorm LLaMA synset using the proposed pipeline. Green indicates that the corresponding page in the Ukrainian Wikipedia was found, while red indicates that the title could not be found, resulting in a gap in the tree. Regarding the general statistics, 23% of Princeton WordNet census are linked to Wikidata, and 17% are connected to the Ukrainian Wikipedia. To handle these gaps, we propose a simple gap ranking algorithm designed to identify the best nodes to fill. This algorithm targets nodes with the largest number of children without gaps in a given tree. For example, the tree on the slide shows that filling the gap arithmetic operation is more efficient than filling the construction node, as the former produces 5 new hypernym pairs, and the latter creates only one pair. The first method for candidate generation uses the English lemma. Which we store in the tree. We translate the lemma using different machine translation systems as indicated in the slide. This approach enables us to quickly produce a list of potential translations for the gap nodes, although their accuracy remains questionable. For example, machine translation can generate Russianisms such as "Kachana kapusta" seen in row 2 of the table, or false concepts like "Holovna kapusta", which even does not exist in the Ukrainian language. Furthermore, the issue of ambiguity demonstrated in row 1 and row 3 presented challenges by offering multiple possible senses. The next method for candidates generation does not use the gap itself, but is child nodes that are not gap nodes. At Naval 2018, organizers presented the Hypernym Discovery task, which aims to generate hypernyms for a given hyponym. We use the architecture proposed by the competition winners, which consists of two main parts, pre-trained word embeddings and logistic regression classifier. The authors used word2vec for embeddings, and in addition to this baseline, we also train fast text, which works better for the morphologically rich Ukrainian language. In the final stages of our work, we tested large language models for hypernym suggestions. To achieve this, we fine-tuned the LLaMA model on hypernym instructions using the parameter-efficient tuning technique called LoRa. For both approaches, we used the same evaluation metrics to ensure a fair comparison of the results. We utilized metrics from the original Hypernym Discovery task and also introduced the mean overlap coefficient metric. This metric indicates the proportion of relevant values that were predicted regardless of their order. To discover hypernyms, we collected a dataset using the created basis of the Ukrainian WordNet. Following the original competition methodology, we used a 50-50 split for training and testing, and also providing a small trial set. Additionally, we divided the input terms into concepts and entities, distinguishing between common and proper nouns. For the instruction-following LLaMA model, we conducted 3 experiments that varied in the types of the instructions and their quantity. Detailed tables comparing metrics for all Hypernym Discovery and LLaMA models are presented in the text of the paper, and on this slide we only compare metrics for the two best models from both approaches and observe a significant advantage of the instruction following LLaMA over the classical Hypernym Discovery model. We conducted a qualitative analysis and noticed that the Hypernym Discovery model tends to overfit for frequently used hypernyms such as metropolis, municipality, and district. However, when these candidates are true hypernyms, the model suggests them as a first option. The instruction following LLaMA appears to be more confident in its prediction, resulting in fewer variants of prediction. For instance, it predicts the single hypernym river for the input term in a car. In this scenario, the problem of overfitting to frequent hypernyms is less noticeable. Additionally, the model can predict relevant hypernyms that are not present in the ground truth set, such as disease for the input word cholangitis and narcotic for methamphetamine. As a result, we proposed a data-driven approach for the automated construction of a hypernym hierarchy for the Ukrainian WordNet. We tested various methods to automatically generate candidates to fill the gaps in the resulting resource. Additionally, we adapted the SEM-eval Hypernym Discovery test to the Ukrainian language and investigated how modern generative AI models perform on this task. In general, this work creates a scalable foundation for building a future reliable Ukrainian WordNet. Since the creation of WordNet is a long process, so there are many areas for future work. The next steps will include creating a detailed instruction manual for annotators, professionally evaluating the syntax that we already generated, scaling to other types of relation and part of speech, and developing an interface similar to the Princeton WordNet to provide a convenient public resource for the Ukrainian language. I thank you for your attention and would be thank you for your attention.